the first thing that I need to share with you guys right now is this. Tomorrow, do not forget, tomorrow is a normal Zoom. I mean, and what I mean by normal is that we are all Zooming tomorrow. Even though it's a half day, I expect you guys to come because we're actually going to switch days. Friday's going to be our iReady day. Tomorrow, we're going to keep working on math, okay? So it is still a half day, so you still show up at the normal half day time. But we are going to do some math tomorrow instead of iReady. All right, so I really quick want to go through the answers of these problems with you guys. So if you take a look at this, okay, for this problem right here, in the example, how can you tell that a negative 38 plus a negative 24 will be a negative without even finding the sum? So without even looking at any of the answers, we know the sum of these two will be negative because when you add a negative and a negative, you get a negative, okay? Because it goes further and further and further into the darks. Oh my goodness. Ah! Oh, phew. I got worried that I was going to lose everything right there. Okay, all right, because when you add a negative into a negative, it is a negative. So now, if you take a look at this problem right here, which one is less? Negative 54 plus 17 or 35 plus negative 61? Okay, well, one method that you could do to figure this out is just by adding them together. So when you add a positive and a negative, remember you're not adding, you are subtracting. So 54 minus 17 comes out to be 37. And since 54 is bigger, it's a negative 37. Okay. Now over here, we're adding a negative and a positive. So we don't add them, we subtract them. So 61 minus 35 comes out to be 26. And since 61 is bigger than 35, that means this is a negative. Now we compare these two. Negative 37 is less than negative 26 because it's further into the dark side. Okay, so this right here is less than. This right here is less than. The other way that you could have looked at this is this. Hey, you know that negative 54 plus 17, this has got a bigger gap in between the two of them. And then this is negative, so it's going to be a bigger negative. Okay, and I know that makes no sense at all. It's going to be a smaller number, basically. Where this is over half. So this number right here is over half of that. So this one's not going to be as big of a gap between these two numbers, even though it's still negative because this guy is bigger. It's still going to be a shorter gap between the two of them. So the answer is negative 54 plus 17 is less than 35 plus negative 61. All right, so hopefully you guys did pretty good on that problem right there. All right, next, what is the sum of negative 21 plus negative 49? So if I were to look at this problem, this is what this problem would look like, okay? All right, now go back to your rules. When you add a negative and another negative, that means you're going further into the dark side. So basically, we're just going to add these two numbers together. So 9 plus 1 is 10, carry the 1. 2 plus 4 is 6, plus 1 is 70. And since they're both negative, the answer is negative. So your answer is negative 70. Okay, look at number 4. Find 15 plus negative 72, show your work. So again, I would not write out all of the plus signs and the negative signs and find the zero pairs. I wouldn't do that. And I don't think I would use a number line for this either because it's going to get a little bit too crazy. So you got two other methods. When you add a positive and a negative, you don't add them, you actually subtract them. All right, so that's a 7. 6 minus 1 is 5. 72 is bigger, and so the answer is negative 57. Or you could zero pair out. And what I mean by that is this. If you have to get rid of 15, you know you're going to add a negative 15 to that, right? That will zero those out. Now, the original problem is this. So you have to break 72 up. So, you know, if you take 15 out of 72, you're left over with a negative 57. So now those zero out, leaving us with just a negative 57. So 2 different methods that you could use. Number 5, which sums are equal to negative 8 plus 17? So guess what? I'm not even going to add these together. Okay, I know this. I know that this 8 is a negative. I know this 17 is a positive. I know this. So therefore, what I'm going to do is I'm going to look for problems over here that are just like this in some way or another. Now, we haven't talked about the distributive property, but when you have a parentheses around this and a negative sign out in front, really what that means is that you're going to multiply that negative sign by everything inside. So this really turns out to be a negative 8 plus a negative 17. Uh-oh, that's not like this one because this 17 is a negative and in our problem it's a positive. So sorry, A, you don't get a play. Okay, look at this one. Positive 17 plus negative 8. What do you know? Positive 17 plus negative 8. So they use a commutative property to move them around. So B is just like that. Okay, look at C. So we have a negative 8. Sweet. Then we have an 8 and 9. Well, what do you know, you guys? 8 plus 9 is 17. So these would be just like this. Okay, look at this one right here. Uh-oh, this isn't right because this 8's a positive and this 8's a negative. So D is not a choice. And then E, both of them are negative, and that's not true because 17 is positive. So your only answers are B and C. Last but not least, the temperature at Wonder Lake is 12 degrees during a storm. The temperature changes by 26 degrees. What is the temperature? So if you look at this, this is what our problem is. 12 degrees is the start, and then it changes by negative 26 degrees. So you have 2 options. You can, when you're adding 2 signed numbers, you don't add them, you subtract them. So 26 minus 12 is 14. Then give it the sign of the larger number, which is a negative 14. Or if you have 12 plus negative 26, if we want to zero out the 12, we would need to add a negative 12 to that. So now we're breaking negative 26 into 2 parts, a negative 12 plus a negative 14. So these zero out, leaving me with just a negative 14. So our answer is negative 14 degrees Fahrenheit. All right, so what I need everybody to do right now, remember I'm videotaping, so please do not unmute yourself right now. But if I could have you guys grab out a piece of paper, we're going to take a couple of notes today, just a few notes, and then we're going to cut you loose, okay? So the first thing that we're going to talk about is adding and subtracting decimals. Now, I have posted in Google Classroom some more notes. So if this doesn't make sense to you, you can go ahead and open up the notes and read through that and see if it will help you. So let's say that we start off with a pretty super simple problem. Let's go with 42 and 7/10 plus 85 and 103 thousandths. Okay. So just like the rapid mathematician said, You got to line up the dot and give it all you got. You got to line up the dot and give it all you got. So we go 42 7/10 plus, we're going to line up the dot. So I have 85. Here's your decimal point, 103. Okay, so we line up the decimal point. Now, for addition, that's the nice thing about addition is that it doesn't matter what one you have on top or bottom. All right, it truly does not matter. But if you look, I have a number in my hundreds and my thousands. So that means I need 2 zeros in here as placeholders. All right, so now I'm just going to go through and add them like I'm adding 2 whole numbers. 0 plus 3 is 3. 0 plus 0 is 0. 7 plus 1 is 8. Bring the decimal point down. 2 plus 5 is 7. 4 plus 8 is 12. All right, so our answer is 127.803 or 803 thousandths. Now, I really want you guys to do this without a calculator. I need to make sure that you guys can do this on your own without a calculator. All right, now take a look at number 2. Now this one is a tad bit different. The reason why this one is a tad bit different is because of the fact that we have 3 terms in this expression. Now, remember that we have something that's called PEMDAS, right? PEMDAS. Please excuse my dear Aunt Sally. So that tells us that we do parentheses, exponents, multiplication, or division, whatever occurs first in the line, addition or subtraction, whatever occurs first. So the order of operations for this problem says that we have to subtract these 2 first before we add that to the last term. So we're going to go line up the dot and give it all we got. Line up the dot and give it all we got. So this is what this problem will look like when you add up the decimals. Now, FYI, if you have a hard time with decimals, you need to use graph paper if you have it. I tell you what, graph paper is a fantastic way to add decimals. All right, and let me show you why. As soon as I get grab a piece of graph paper here. Maybe. There it is. Okay. I'll show you on the next problem how graph paper is so awesome. Well, I'll just show you really quick. So if we have 68, here's my decimal point, 91 minus 17 decimal point. The nice thing about graph paper is it keeps all of your place values all lined up. So if you have graph paper, I would use it. It will help keep you super organized. Okay. All right. So now if you look, I have the thousands place, but I don't have anything up here to take 4 away from. So I got to give this a value of 0. Now, can you take 4 from 0? Yeah, you can, but it turns out to be a negative. So what we do is we go to the hundredths place and we're going to borrow 10 hundredths from that. If we borrow from that, that makes that a 0 and this transfers over 10. Now, I know you guys have ways of doing it, and some of you guys cross this 0 out and actually make a 10. Whatever you want to do is fine. So 10 minus 4 is 6. All right, I can't take 5 from 0 because it gives me a negative. So I go to my tenths place and I borrow 1 from that, which makes this now an 8 and this now a 10. 10 minus 5 is 5. 8 minus 8 is 0. Here's my decimal point as a placeholder. 8 minus 7 is 1, and 6 minus 1 is 5. So this first part, when you subtract 68 91 hundredths minus 17 and 854 thousandths, comes out to be 51 and 56 thousandths. Now I'm going to add this last part. So again, line up the dot and give it all you got. Now, if you look, this ends in the thousands, this ends in the hundreds. So I'm going to add a 0 as a placeholder. And let's add. 6 plus 0 is 6. 5 plus 0 is 5. 0 plus 2 is 2. 1, bring down the decimal point. 1 plus 4 is 5. And 5 plus 6 is 11. And so that would be your total answer for that expression. Okay? All right, so now that you guys, I feel really good about how you guys were able to add and subtract decimals. So let's talk about adding and subtracting fractions. Now, if you guys had a normal fraction, so adding and subtracting fractions, all right? The key thing about adding and subtracting fractions is this. You must have a common denominator. You must have a common denominator. Okay, you must have a common denominator. Okay, all right, you have to. All right, so if you don't have a common denominator, it is your job to get one. Then once you get a common denominator, then you just add the numerators together. Okay, you add the numerators and keep, this is the big one right here, the denominator the same. All right, and here's why I'm saying this. All right, I'll come back to this in just a second. I cannot tell you how many times I have students that if I ask them to add 2/5 plus 1/5, all right, they end up getting 3/10. That is incorrect. Because I want you to think about this. 1, 2, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, 2/5 looks like this, right? If we add 1/5 to that, we have a total of, sorry, bad example, 3/5. Not 3/10. It's just 3/5. So please don't make that mistake. Okay. So again, when you add fractions, you must have a common denominator. Okay, get a common denominator before you do anything else. All right. Okay, so with that being said, let's take a quick peek at this example. So actually, we're going to start off with an easier one first. Well, not easy, but easy enough. So if you, let's start out with 4/7 plus 3/14. 4/7 plus 3/14. Now, I don't know about you, and I don't care what way you do it, all right? But you could keep it this way. Personally, when I add fractions together, I like to do it this way. I just like it. Now, in order to add these, you have to have a common denominator. That common denominator is actually the LCM. LCM, 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 which is called the least common multiple. All right, so multiples. If we go down here, the multiples of 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Yada, 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 yada. Okay, 14 would be 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is blah, 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 blah. Because I can stop because look, I already have common numbers here. Least common multiple means the smallest. So therefore, I know that 7 and 14 both go in to 14. Now you say, what do I do to 7 to get 14? Well, I multiplied it by 2. So then you have to multiply the top number, the numerator, by 2. 4 times 2 is 8. Okay, so these now are called equivalent fractions. 14, oh, look at us, yay, it's just times 1, so this is 3. So finally, I'm just going to add my numerators. So this becomes 11/14. Now, like I said, I personally like to do it this way, which is the same. So 14 is still my common denominator. 7 times 2 is 14, so 4 times 2 is 8. This is times 1, so nothing changes. So add my numerators, and I still get 11/14. Okay? All right? Okay, so now let's take a peek at another type of problem, fractions. All right, but this time what we have is we have 3 fractions that we have to deal with. Okay, so again, what we're going to do is we're going to solve these first because order of operations makes us do that. So like I already told you, I personally like to do it this way, right? Okay, and again, it doesn't matter. If you want to do it the other way, I don't care. It totally doesn't matter. So now, first thing, like we talked about, you have to have a common denominator. So you need to find the least common multiple of 12 and 8. So we'll start with 8s. So 8, 16, 24, 32, 40, and I'm going to stop. 12 is 12. 12 times 2 is, ouch! Woo, 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 woo! I found a winner, 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 chicken dinner. So 24 is my least common multiple. So 24 is going to be my new denominator. So now I ask, 8 times what is 24? 3. So 5 times 3 is 15. Okay, all right, 12 times 2 is 24. So 7 times 2 is 14. All right, so now this is subtraction, so I'm going to subtract. 15 minus 14 is 1, and my denominator stays the same. Now I'm going to finish this off by adding the last part, which is 1/4. Okay, so now I got to go. Ready? 4, 8, 12, 16, 20, 20. Ouch! Lucky me. Look it. That would be my least common denominator, least common multiple. So this one doesn't change. 4 times 6 is 24. So 1 times 6 is 6. And last but certainly not least, we add our numerators and our denominators stay the same. Okay, so the result of this is 7/24. Now, you guys, I don't care. You guys could have done this from the get-go. You guys could have gone 15/24 minus 14/24 plus 6/24 and gone 15 minus 14 is 1. 1 plus 6 is 7. It's the same answer. I just want to make sure that it is step by step. Okay? All right. And last but certainly not least, the last thing I want to talk to you guys about is when you have to add mixed numbers together. So a mixed number would be a whole number with a fraction like this. All right. So what I do is I write them like this again. So 2 3/4 plus 3 1/4. I like to do it this way because it's just easier. Woohoo! High five! Yeah, skippy dippy, because I have a common denominator. So that means I'm just going to add my numerators. So 3 plus 1 is 4/4. And then 2 plus 3 is 5. Well, 4/4 is 1 whole. So 5 plus 1 more whole is 6. Okay, so I added my fractions, I added my whole numbers, and then I simplified them down. Okay, so really no difference. The only difference is that you have whole numbers in front of it. Okay, look at this problem. 6 6/7 minus 4 5/14. So first step is we're going to take care of our fractions. We got to come up with the least common multiple. So the number that 7 and 14 both go into is 14. So this is just times 1. So this stays 5/14. This times it by 2 changes to 12/14. Now I subtract. 12 minus 5 is 7. My denominator stays as 14. Now do my whole numbers. 6 minus 4 is 2. All right. And this needs to be reduced, aka simplified down. So a number that goes into 7 and 14 is 7. So this simplifies down to 2 1/2. Okay. All right. So hopefully you guys don't have a ton of questions on that. But again, there's so many resources out there. So if you do have questions, Google adding decimals, Google adding fractions. There's so many awesome resources out there. So here's what you guys are doing today. All right. So assignment number 1 is located in your classwork. All right, it's under classwork. It's assignment number 1. Got it? All right. You probably you're using Kami. So do the work on another piece of paper and transfer your answer here. Do not use calculators. That does not help you learn how to add fractions and decimals. Okay. All right. Assignment number 2 is also listed under classwork. All right. It's called assignment number 2. All right. And I think it's called adding mixed numbers. Assignment number 2, adding mixed numbers. All right. So again, do the work on a separate piece of paper and then put your answer on here.